And good morning. We're ready for section 19.2 in math. So let's get started. So now that we know more about angles, how to measure angles, we did that earlier in the other lesson. We're going to take a look now at how many degrees some common angles are, how to draw angles to a specific size, and then how to add angles together. So first of all, let's do naming angles. Let's see. All right, so while you might not think of a straight line as an angle, we could really think of a vertex as occurring anywhere on the line. If it did, the angle formed would always be 180. We call this a straight angle. So a straight line is measured at 180 degrees because it goes from the 0 on one side all the way over to the 180 on the other side. So it's a straight angle. You would never think of that, but it is. All right, look at the top of 371. Notice that a right angle is 90 degrees. Just like a straight line, all right angles have only one measurement. So if somebody says a right angle, automatically, bam, you know it's 90 degrees. If someone says a straight angle, bam, you know it's 180. So an acute angle, however, is any angle less than 90 but greater than 0. This one pictured is 40 degrees. See that? It's less than 90, but it's more than 0. All right, an obtuse angle is any angle greater than 90 but less than 180. This one pictured is 125 degrees. Okay? All right, now drawing angles that are a specific degree is easy. Basically, you keep the protractor, well, it says keep the protractor out. So you use the straight edge of the protractor, the very bottom part, to draw a straight line. Okay? Then you rest your protractor on the line, and that little dot that's right in the very center, you align that where you want that vertex. And then you go up and you put a mark wherever the degree is that you want. And then you move your protractor over and you draw a straight line from your vertex all the way up to that line that you wanted. And voila, you have an angle. Now, and just when you might need to draw, when will you need to draw angles? Well, up until now, you've drawn shapes without worrying about exact angles. But if you were trying to draw a scale drawing or blueprint, it'd be important to get the angles accurate. And using your protractor, you can do that. For example, if you know you're drawing a rectangle, a parallelogram with right angles, you can begin by drawing a straight line to represent one side. Then, since you know a rectangle has 4 right angles, it's part of the definition of a rectangle, a parallelogram with right angles, then you know you need to make the next side intersect at a right angle. By making all the angles in the rectangle right angles, you also end up with 2 pairs of parallel lines. So at the top of 373, it shows you what you end up with. Now we're going to add angles. Not only is it helpful to name and draw angles, it's also helpful to add them to see their total. We can add them numerically, just like you would any other number. 20 degrees plus 30 degrees gives you 50 degrees. So notice that if you actually had angles those sizes and you put them together, the larger angle formed would indeed be 50 degrees. Along with other things, knowing how to add angles can help us draw or measure an angle greater than 180. While a protractor stops at 180, you can view larger angles as the addition of 2 smaller angles. You can draw or measure the larger angles by drawing or measuring 2 smaller angles that sum to the desired larger angle. So here's an example. Draw a 200 degree angle. Well, that's kind of hard when your protractor only goes to 180. Well, to do this, you're going to draw 2 smaller angles whose sum equals 200. So what they did was they drew a 100 degree angle. They just drew a straight line across. Then they put their protractor on that line where it needed to go, and they put their mark up beside 100. Then they drew a straight line up, got a 100 degree angle. Then what they did, they went to the other side, and from that straight one up, they drew another 100-degree angle. 100 and 100 gives you a 200-degree angle. Notice where this angle is. This is on the outside of where you might see the inside angle. Notice that? This is what I was talking about in the last lesson. It doesn't matter what two smaller angles you draw so long as the sum equals 200. Here's another one. Here they just drew 180. They just drew a straight line. And then off of that, at the vertex, they drew another 20-degree angle because 180 and 20 gives you 200 degrees. Doesn't matter how you do it. Look at the back of, or look at the page 374. Here's an example. Measure this angle shown. Notice this is kind of the outside of the angle. It's what I would consider the outside of the angle, because I always think of an angle as being the inside part, but the outside part's an angle too. Since this angle is greater than 180, you can just look at it and you know it's greater than 180. You'll have to measure it by dividing it into two smaller angles because you can't measure more than 180. So you'll have to draw it into two angles. So what they did was, you see the straight line across? Notice, look at the one at the top and then right there at the bottom. They just drew another section over from the 180 and made it a straight line and called it 180. Okay, then they measured from the vertex, which would be the very center where that other angle is, they measured that and it was 60 degrees. So 180 plus 60 is 240. So that angle at the very top is 240 degrees. Does that make sense? I hope that makes good sense to you. There wasn't really anything for me to show you. They showed you everything very well in here. All right, look at your worksheet, 19.2. Now this says you can use a calculator on the back. The back. Skill sharpening, 5 and 6, you can use a calculator. All right, so on 1, A, B, C, D, E, and F, we're going to be drawing angles. So what I'm going to do is I'm going to get my setup done right here, and then I'm going to help you draw these angles, okay? All right, here's my setup. Well, you ought to see it. It looks awfully funny on my desk, but that's okay. Alrighty, let us go ahead and on worksheet 19.2, the very first one on A, it wants us to draw a 120 degree angle. I'm going to skip down. It wants us to draw a 120 degree angle. Okay, so what we do first, get your protractor. I know, let's see, mine looks crooked. Okay, let me get mine straight. It looks crooked just because my camera's crooked. Alright, so we're going to draw just a straight line. Doesn't matter how long. Okay? So just draw you a straight line. Does not matter how long. It needs to be 120. Alright, when we're done with that, then this is going to be our vertex. So that's where we put our little dot over that. And we got to line this up. Remember we did that yesterday or in the last lesson. Line this up real well, okay? It looks just right. Then, I don't think I did mine big enough. I'm going to have to turn mine around because I didn't do it big enough. So this will have to be my vertex. And I got my thing around backwards. Okay. There we go. You see that? Got that right there on the vertex. Got my line lined up here. Everything looks just right. All right, now I'm going to find 120. Now, if I did 120 here, that would be a very small, that would be a small triangle, so 120 wouldn't work. So that means I've got to use these numbers on this side because these are the 0 numbers here on this side. So I'm going to go all the way to 120, which would be right here. So I'm going to make a mark right there, right above the 120. Okay. Then I'm going to turn my protractor this way. I'm going to line it up with my vertex and my line that I drew. Get it just right in there. Ta-da! There's my 120-degree angle. Okay? All right. Let's see, I know you can do B. That's a perfectly easy 190 degrees. C, okay, let me help you with F. That's one that's bigger than 180. So F wants you to do a 225-degree angle. Okay, 225. So let's go ahead and do a 180. Let's see, what's half of 225? Let me see. 220, I can see what half is. No, we're not going to do that. All right, we're just going to do it. We're going to do a 180. I know this looks crooked to you. There we go. All right, so we're just going to just draw a straight line. So we know it's 180 because a straight angle is 180. Now, I'm going to use my calculator and I'm going to figure out 225 minus 180, and this will tell me what I have left. Now I got to do a 45-degree angle off of this. Okay, so here's my 180, but I need 225. So I subtracted 180 from 225 and I got 45 degrees. So that means what I want to do, now I don't want to do it from here or from here because that would mean that it would be just this angle. And that's not what I have to do. I'm doing 225. So that means my vertex is actually right here, right about in the middle. Because remember, from one side of the protractor to the other is 180 because it starts at 0 and goes all the way to the other side. So that's why it's 180. All right, so I'm going to start with my vertex right here, line everything up. Okay. Now I'm going to go ahead and do 45 degrees. Now I'm using the numbers up here because I'm starting with 0 on the side. So I'm going to go to 45, which would be about right here. Okay. So there we go. Was that right? I'm not so sure that's right. I might better check in my teacher book. That does not look right to me. That looks like 40. This would be 45. And then this would be, yeah, that's not correct. I have told you wrong. Let me see here. What did they do? Oh, yeah, it's not this angle. Well, this is 45 degrees, but that's not the angle. Remember, the angle's on the outside. I did do it wrong, but the angle's on the outside. But this angle's 180. So what we'll have to do is we would actually have to, I did it right and I did it wrong. So basically, you would have to remove this line, and your angle would be this, would be the 225 here. Okay, let me show you again. Okay, so we're going to do our 180. The paper's crooked. 180. Okay, 180. Remember, it's a straight line. All right, and then we have to do a 45-degree angle. Okay, so this would be 45 right here in the middle. Okay, so I'm not going to be able to really do it very well with my pen because I should erase it. Now, pardon me. So then if I had a pencil, I would erase this because my 225-degree angle is this on the outside. Okay? Does that make any kind of sense at all? All right. That's how you would do a bigger angle. Just draw your 180. Actually, there's two different ways that it tells you could do it. I'm not so sure I picked the favorable one, but it says drawing the 200. There is a note. It says that it does not matter what two smaller angles that you draw so long as the sum equals 200. So it wouldn't matter how it would be, but as long as it would equal 200, the two of them. Okay? All right. I think that is it that I need to help you with. I think the rest of it you should be able to do yourself. Now on part 3, you're going to have to use a protractor to measure. On number 4 on the back of the page, it says give a scale drawing a try by making a scale drawing of a rectangular window that's 4.5 feet by 3.5 feet. This time don't use graph paper, instead use your ruler and compass to get straight lines. Compass and right angles. Hint, use an inch to represent a foot to keep it easy. Start by drawing a line 4.5 inches long, then draw a 90-degree angle, making the line forming the angle 3 inches long. Draw another 90-degree angle, making that line extend 4.5 inches long, then another 90-degree angle, making the line extend 3 inches long. You'll end up with a rectangle with 4 90-degree angles and 2 sets of parallel sides. Basically, you are going to use your protractor to draw a rectangle. So it would be something to the effect of this right here. So it's saying that you're going to want to use 1 inch because it's a scale drawing, and the scale is because it's 4.5 feet by 3.5 feet, but it's wanting you to use inches. So 1 inch would equal 1 foot. So if you do 4.5 inches, that in our scale drawing, that's going to be 4.5 feet. Okay. Then it says it wants you to form a 90-degree angle, and then it wants you to do 3 inches long. And then another 4.5, and then your other 3. That's really all that it's wanting you to do. But then it's wanting you to show, you might even want to put a scale in there to say 1 inch equals 1 foot. That'll just kind of show you the scale. Anyway, that's just kind of practicing with that. So I think the rest of it you probably should be able to do yourself. So if you need any help, just let me know.